Kalpana ma'am, are you there? Can we start with the session? Once you're ready, please let us know.
Hi, Subha. Good evening. I'm ready.
Yes, ma'am. Just a few minutes. Hello, everyone. Our next session is on building trust in AI, ensuring transparency and explainability by Ms. Kalpana Kadriwal. Ms. Kalpana is an experienced data science professional with expertise in machine learning, deep learning, and data analytics. She is passionate about leveraging data driven insights to solve complex business challenges and improve operational efficiency. Currently, she serves as an SME manager and AIML trainer at Data Mites Bengaluru. It's our honor to have you here with us, ma'am. A very warm welcome to you for the session. You can take over the session ahead, ma'am.
Hi, Subha. Thank you so much for your introduction. Hello, everyone. Good evening. Let me share my screen. Hope my screen is visible.
Yes, ma'am.
Okay. Yeah, as you all know, today's topic is going to be building trust in AI. So, as we all have started using AI a lot, so you can see the impact of AI in today's life, right? When you talk about any domain, any industry, we started using machine learning, we started using AI, right? So already AI has a huge impact on our day-to-day life, right? Which you will agree. So Facebook algorithm decides what ads you should see, what posts you should. I'm sorry. I see
Participants
that.
kindly mute your mic.
પછી તા ચાર્જર આપણને અડવી નહીં ગમે એટલું ફાસ્ટ થાય 20 મિનિટમાં
They
જો આઈ
forgot
ગયું
to mute.
Sorry. Participants kindly mute your mic.
I hope it's fine now. Okay. So we all know that in our day-to-day life, how much we started using AI, how much we depend on it, right? So there are many examples that you can have. So you know Facebook earns a lot from ads. So it knows what ads you would be interested, right? But how it knows it? So the algorithm, the AI algorithm understands in what kind of content you are interested, right? Based on the status that you update in Facebook, right? So it just analyzes your data. It understands, what you like, what you may be interested in, and it could understand what kind of ads you might be interested in, and it posts such, or it you know the algorithm post ad that you might be interested in, right? And these days everybody uses Google Map, right? So whatever route it suggests, you blindly take it, right? So again, how that is being done, right? And Netflix recommends you videos that you might like, Amazon recommends you the products that you might like, that you might purchase, right? And let's say if you want to plan a trip, right? Or if you want to travel, so you try to understand what would be the weather there, right? So you do, there are AI models which does weather forecasting, right? So these are just few examples, but probably you might be knowing what is the impact of AI in industries, in business, even in your day-to-day life, right? Not just this, AI even started taking critical decisions for us, right? So it even does predictions on critical scenarios. Let's talk about hospital scenario. So you can have a model which can predict a disease, which can recommend you the specialist based on the symptoms that you have, right? So my question is, how do you trust AI? Have you ever questioned, right, how AI gives you this output, right? Whether you can trust or not, whether you can take it blindly or not, right? So have you ever thought about that? Hmm. So you use AI models to diagnose disease, right? To analyze your scan reports or X-rays, right? So how do you make the client use your AI model? Let's say you built AI model, right? How do you make them believe your model or use your model, right? Do you know that in somewhere around 2016 or 17, they developed a model for analyzing the X-rays. Okay. While testing the model, the accuracy was very good. Okay. It even showed a high level accuracy like a radiologist. Okay. The model name was ChexNet. I think it was developed around 2017. Okay. So it was showing a very good accuracy when it was tested with the data. Okay. With the test data they had. But when the model was deployed, it actually failed. Okay. The accuracy significantly decreased. Okay. So even the people who developed the model could not explain the performance, could not explain why it was not able to predict accurately, right? So the researchers had no idea, like on what basis the prediction is done, right? The same question would come in our mind when you talk about any AI model, right? Any deep learning model that you build, you must have come across many machine learning algorithms, right? You must have had linear regression, logistic regression, right? Where these are simple models. You can understand the mathematical behind these algorithms. You know how they learn the data, right? When you talk about linear regression, you know how it learns the data, on what basis it predicts the output. You can understand the parameters of those models, right? You can understand which feature it had given more importance, right? From where it had learned more. But on the other hand, you have deep learning models, right? Even you talk about boosting algorithms or bagging, right? So how do you understand the performance of, how do you know how it learns? Which feature it had given more importance? These machine learning models or even the deep learning models that you have, they learn in darkness. We exactly don't understand which input feature had influenced this prediction, right? Which feature had had greater impact on a certain output. So you may not be able to tell that because we don't know how these models learn. How do they understand the data, right? How do they predict or give certain output, right? So when you had no idea of, maybe you can understand the architecture, but when you have no idea of how these predictions are made, right, then there would be a question like, how can I trust this model, right? Let's say you built a model and you give it to doctors, and how do you expect the doctors to use your model to predict or to do diagnosis for the patients, right? So to address all these challenges that we had, right, to build trust in AI, we came up with explainable AI. Okay, so explainable AI helps us in understanding uh, the architecture, not just the architecture, to understand how the model has arrived to certain prediction. Okay, on what basis it has given us a certain output. So let's understand this in detail. So when you talk about building a reliable model, transparency becomes important, explainability becomes important. These sounds similar, but they are different. So what is transparency is about? What is explainability? When you say transparency, it mostly talks about the process. Okay, so let's say I want to know how this model was built, how it learned the data, from where the data comes, right? Whether the data is biased or not. So it just talks about the process. Okay, whereas explainability talks about how did I come to this out? How do the model gives me this output, right? How can I understand? How can I take this prediction? How can I trust the model, right? It's about reasoning. It explains you how it had come to a conclusion, how it gave you the output. Okay, which is very important, right? So when you use your model for healthcare domain or for financial domain where some critical decisions are made, right, where you have sensitive issues, right, there all explainability becomes very important, right? So we will understand what are the different techniques we have to explain the predictions of a model, right? So when we particularly work with black box model, so black box is nothing but like when you don't really understand how the model learns, right? How the model predicts the output, right? So usually we call AI models as black box model, right? Because you really don't know what's happening inside. You just pass the input and the model learns and you don't know how it learns and you get some output, right? So we really don't understand how the model learns the data. So such models we call as black box model, right? And explainability is where you try to understand how the model how the model gives you certain output. So transparency, as I told, it talks about how your data is. Okay, let's say if we don't have transparency, what would happen? So let's say you may not know what is the source, right? From where am I getting this data? Whether is there, whether is it legal to use that data, right? Whether it is biased or not, right? So you need to have transparency. You need to have a proper documentation of your data. You need to know whether this data is not biased, or let's say you cannot use some private messages, right? So is there the does it does it ensures the legal and ethical use of data or not? So you need to have a proper documentation for your data, which explains what is the source, from where the data comes, who owns this data, whether it is legal to use it or not, right? Whether it is unbiased, right? So this can be achieved, as I told, with a proper documentation. Okay, data transparency is also important, not just explainability, right? So let's say when there is no transparency, then even if you explain your model, explain the predictions, it's just going to be a polished lies, right? So transparency is important, right? And when you talk about explainability, So as I told, explainability, like you have a lot of techniques to explain the model's output, right? So there are different approaches, but what is the importance of explainability? So the first thing is trust, right? Because if you want people to trust your model, right? If you want the end user to trust your model, then you should be able to the uh, explain the process, or explain how it had given you how it is able to predict something, right? Whether you can trust, whether you can take the output or not, right? Whether you can rely on the model or not. So trust is a main factor which comes from explainable AI, right? So when there is a trust factor, then you can see user adaptation, right? It increases, right? Your client or end user will use your model, right? And ethical compliances. So let's say if if you're able to explain, right, then explain the model, then it ensures that there is no AI no discrimination, right? You must have seen a lot of examples before. Like, let's say, there was a case where IBM had built a model, a facial recognition model, okay, in 2018, where this model was biased. Okay, so IBM developed a model, okay, where this model was biased with the skin tone. If it had um, uh, a dark skin, people with dark skin, they were identified as I'm sorry, if someone wants to say something. Okay, yeah. So they built a model which was actually biased, which had a different, treatment for, I mean, when I say treatment, like uh, for a dark skin toned people, it showed as, high risk, and for a light skin tone people, it showed low risk. Okay. And there were, even a model for hiring, okay, which was gender biased, okay, which was gender bias. So it hired mostly men, okay, considering that they are the most eligible candidates, okay. So these models were not, I mean, they were tested, right? But based on the data, it learns, right? Based on what data you have given, it learns. So let's say if the data that you had, where most of the male employees had been employed in that company, then the model that you have trained, right, has a gender bias, right? So this was a case which happened before. So these kind of bias can be avoided when you explain on how the model has predicted something, right? You could understand whether is there any bias which you can control it, right? So you can see whether your model follows all ethical compliances, right? And of course regulatory adherence, right, whether it meets a legal standard or not, right? And reliability, right? So you can increase the the trust factor again, right, when you could explain, when you have explainable AI. So these are the importance of explainable AI. So without explainable AI, You either blindly trust your model, right? And you would see when the model, when the AI model hallucinates, right, where it gives you uh, the the false information with high confidence, right? So that could happen, and there might be high risk, in terms of um, let's say if there would be some kind of bias, as I told, right? Let's say if you talk about the court cases, where if you rely on a model where the model is having some kind of discrimination, where there would be high risk when you use such models in real time, right? And lack of reasoning, where you don't really understand how how on what basis it has given you this output, right? So these things would happen when you don't have explainable AI, right? But with explainable AI, you can understand from where the information comes from. What is the source? Let's say when you type something in ChatGPT, when you ask something, it gives you the answer, right? Which you blindly take it, right? If you ask anyone whether this ChatGPT answer is correct or not, they would be very confident that 100% it is true. But who knows, right? From where it is taking the information, right? So when you have explainable AI, you can understand, you can get the fact, you can see from where it has sourced the information, right? So from which article it has taken, right? From what document it has referred, how did it pull the information? How did you give the information, right? So you can understand the source, right? And you could have the trust. So you don't have to blindly trust it, or you don't have to have a zero trust, right? You can understand how much trust I can have in this model, right? So you can be sure of your model. And you know that LLMs don't take the entire sentence, right? It takes each tokens, so you can understand which word is more important, or which uh, character is being focused more or given importance more, right? On what basis the decision is made, right? You can understand that, and you can do a safer deployment, right? When you can see whether you have the proper usage of technology or not, if you are confident about that, then you can have your end users using your model with full confidence, right? So when you say explainability, there are two approaches. There are models which is explained by design. They call it as intrinsic explainability. As I told, we have linear regression, logistic regression, decision tree. We know how they work, right? We understand how the mechanism is, like how it learns the data, right? It is quite interpretable. So by looking at the architecture, by looking at the mathematical part of any algorithm, you can easily understand how does it learns the data, how it had arrived to some decision or some conclusion, right? They are very simple models. As you have linear regression, logistic, these are very simple models, okay? And you know how does it gives you certain output. But there are some models, as I told, black box models, where you don't you cannot talk about the architecture, you cannot understand how it learns, but you can see when it does a prediction, you can understand how it has given you certain output. So in we call that as post hoc explanation, where you can have any kind of model, you can explain how the input and output is related. So how for certain inputs we got this output, so based on analyzing the input and the output, your it explains on how this output has been given. Okay, so we have a lot of techniques, explainable AI techniques, which has a different way of working, which gives you a different kind of explanation. So we will understand some of the techniques here. So when you talk about LLMs, large language models, so what kind of challenges do we have when we deal with LLMs? Why explainable AI becomes very important here? See, when you build any LLMs, you see a lot of parameters, right? You will have billions of parameters, right? You will have lots of features feeding into these LLMs, right? So how do you trace it? How do you understand which of these layers have more influence on a prediction, right? So you talk about the complexity of a model. So you will have billions of parameters, you'll have a lot of layers, right? So how do you understand where the model focused more, right? At which part of layer or which parameter, has more influence on a certain output, right? So when you're dealing with complex models, it is becoming really difficult to do any kind of mathematical calculation, manual calculation. To understand, how the model's learning is, how the process is. That becomes little difficult, right? And mostly LLMs gives you uncertain outputs. You cannot expect accurate output from a model, right? Let's say if you talk about next word prediction, based on the given input, it understands what could be the next word, right? It gives you a probabilistic output. So when the output itself is not very certain, it's coming on a probability. How do you, how do you understand, how does it gives this kind of predictions, right? So that's again something which is very challenging, right? And context. So when you give any sentence or paragraphs to LLMs, they don't take the entire, they don't give any importance, or they don't get the context from any single word, right? It has to understand the concept from the given, um, you know, inputs, right? It has to understand how these features are, how these inputs or concepts are spread across the layers. That kind of understanding is lacking, right, when we deal with LLMs. So there are many other challenges that we have when we deal with LLMs, right? So when we talk about a non-linearity, right, you have a non-linear architecture. So where you don't really understand, how it works. So to deal with all this, explainable AI becomes very important. So here are some of the techniques we have. We have Lime, we have Sharp, counterfactual, chain of thought. So there are many other techniques. We have attention visualization. We have lot many techniques. Okay. So these are some of the pre-trained models which helps us in understanding the prediction of a model. Okay. But each works in a different way. So we will understand some of the techniques here. Okay. So when you talk about LINE stands for local interpretable model agnostic explanations. So as the name itself says, uh, this is an interpretable model. Okay. So model agnostic stands for, like, you can use this technique for any kind of model, whether you deal with machine learning model or whether you talk about any deep learning techniques, right, or LLMs. You can use this technique for any kind of model. So what this Lime actually does, how it works, let's understand. So when you see, LIME does not explain the prediction of the entire model. Let's say um, you give thousands of test data points. The model has given you some output. So you're not going to explain the output of the entire data. Okay, LIME focuses on one instance. It takes one data point. It tells you how the model has predicted the output for that instance. Okay, let's take an example here. So I have a text, okay, which is predicted as spam. So you can see the message here. This is our data. Congratulations, you won a free lottery. Click here to claim now. So this is the text that we have. And some classifier model has been used where the model's prediction is spam. Now, the question here is how did this, this text was predicted as spam? So how does LIME explains you that? Okay, let us understand. So what LIME does, it generates some modified versions of this input data. So let's say this text data. So this is our original image given to the model, original text given to the model. And what LIME does, it takes that instance, it takes that text, and it creates a slightly, modified version of that email. Okay. So let's say, for example, this is one version of your text where this lottery word is removed. Okay. And instead of lottery, it assigns a different word. So it just slightly modifies your text. It creates thousands of such emails. Okay. So to explain one instance, to explain the output of the model, it takes that text and it gives you hundreds or thousands of modified emails based on the text that you have, based on the email that you have. So it slightly modifies the statement. So it removes some of the words, or it masks some of the words, or it replaces certain words with a different word, right? So it creates thousands of emails like this. And again, it feeds to the model and allows the model to predict the output. So again, the classifier will give you the output here saying whether it is spam or not spam. Let's say, for example, here if it says not spam, here it says spam. So here it says spam. Here it says spam. Here it says not spam. Okay. So this is for an example. So it just creates thousands of emails like this. Okay. And it allows the classifier to predict the output here. Then it understands what is the influence of certain words in this prediction. Okay, it analyzes this with another linear model. It just passes this data to a simple model. We call that as surrogate model. Okay, so what it does, it creates thousands of models, thousands of emails from the original email and does the prediction. Okay, it makes, it has a model to predict the output. It takes the same model to predict the output for those 1,000 emails. Okay, and then this data will be given to a linear model, a simple model like a logistic regression, where that model will try to understand which features had actually more influence on the output, how the output changes with respect to certain changes in the input, right? So this gives you the weight for each feature. It calculates the weight So here again, we use some linear model, okay, and understand what is the weight of each feature, how each feature influences the prediction, right? It is analyzed by this linear model. And based on the weights for each feature, it understands which is the most important feature. Okay, which is the most important word in that email, which has greater impact on the prediction, whether it is lottery or whether it is free or whether it is click here, right? It understands that by by doing some variation in the original email and based on the prediction that the model has done. So this data is being analyzed to understand which part of the email is very important or has on the more impact on this prediction. Okay, so it's a very simple technique. So it just uses a linear model which analyzes the changes in the data, the changes in the prediction based on the changes in input, and identifies the important feature. So this is one technique which explains you based on what word it has flagged the mail as spam. Okay, or how it identifies text as spam, how it identifies a mail as spam. So if those words are present, then obviously they are spam emails, right? So this is explained with the weights for each features. Okay, so this is the process of LLM. But it cannot talk about the entire data. It only takes one instance. Hence, we call it as locally interpretable model agnostic explanations. It can be used for any kind of model. So it can be used for LLMs. It can be used for any deep learning techniques, right? Or for any machine learning model. So you can explain how the model has arrived to certain output for any specific instant using line. Okay. So these kind of weights would be assigned for each feature, okay, each word. So with which you can understand which is which word is more important, right, to do this prediction. So if you have a positive weight, it means that they contribute more, right? If those words are there, it is uh, highly possible that it could be a spam mail, right? And if you see any negative weight, then it means that it could be a normal email, a normal text. Okay, so these kind of weights will help us to understand which word is more important. So this is how Lime explains or it justifies its prediction, okay, the model's prediction. So this is one technique we have. And then we have something called as counterfactual. Here, instead of talking about how the model predicted, we talk about what kind of change in the input can actually change the output.
ಇಲ್ಲಿ ಹೋಗಿ ಲೆಫ್ಟ್ ಹೋಗ್ಬೇಕು.
Yes.
ಅಲ್ಲಿ ಹೋದ ತಕ್ಷಣ ಹೋಗುವಂತ ಆಗತ್ತಲ್ಲ.
What happened?
ಇಲ್ಲಪ್ಪ. You are ready.
I think someone is on.
ಬರ್ಬೇಕು.
ಇಲ್ಲ sometimes ನಂಗೂ ಹಂಗೆ ಆಗುತ್ತೆ.
Can you please mute yourself?
Ma'am, your mic is muted. Hello? Hello, ma'am? Hello? Hello, ma'am, your mic is muted.
Can you hear me?
Yeah, ma'am.
Since when it is on mute?
Just last 2 seconds.
Thank you. You can see my screen, right?
Yes, ma'am. Yes.
Okay. So counterfactual is another technique where you don't really talk about the model's prediction. You don't see how the model has given you this output. Rather than you talk about what change can actually cause change in the output. So let's say if you use a model for predicting the heart disease. Let's say if the model says that this person will get heart attack or any heart disease, right? So how do you give a counter fact that what can be done to avoid getting heart attack? So this kind of fact can be given by this counterfactual technique. Okay. So when you talk about loan approval system, let's say you have built a model to predict whether the loan will be approved or rejected. So of course this system has to analyze the applicant data. It has to understand what is the income, what is the credit score, what is the what is his age, right? So different information will be taken to understand whether this applicant is eligible for the loan or not, right? So let's say if the model says that this person, the loan is rejected, right? So how do you convince the customer, right? How do you um, make the customer understand? Like you cannot just say that it is the AI's prediction, right? You need to um, understand, like explain the customer of what can be done if the loan has to be approved. That's something which you can do with counterfactual technique. Okay, so this actually tells like what can be the counterfact, what can be done, or how the input can be changed so that you get the desired output. That is explained by this technique. So you say that, hey, if you have more income, or let's say if you have a good credit score, you would get the loan, right? So you come up with a fact saying that this is what to be done if you want to have a desired output, right? So this is another approach, another technique that we have, to explain or to give a counterfact. Okay, so this works in a way that where you give the instance to the model, a black box model, and when you have a negative feedback or a prediction, right, that is been sent to using some AI library, explainable AI library, where you have this counterfact. It can it can give you the counterfact. It can tell you what has to be done to get a positive prediction. Okay, so this is another technique we have. So we do have something called as chain of thought prompting, where here you can have a prompt to your model saying that, hey, when you give this output, explain the process, explain the reasoning, like how did you come to this, how did you give this prediction? So you could include a prompt, okay, to your model saying that with the output you also want to know how does it uh, give you that output. So which feature it has focused more, or from which feature it had learned, right? On what basis it has done a certain prediction that is given by, that is explained by the model. Okay, so this is another technique we have, and we do have something called as sharp. Maybe I can take you to this. So where SHAP is another technique. It stands for shapely additive explanation. So this is another technique which is very popular. It can be used for LLMs or any machine learning models or any deep learning techniques. So this gives a score for each feature. This is based on game theory, where you try to understand, let's say, when you have 5 features, okay, to predict the output. For each feature, it gives you some sort of score, okay, which is called as sharp values. It gives some kind of a score based on the influence of each feature. Okay, what is the contribution of each feature in a prediction, in the prediction, right? So based on the contribution, it gives some score. So you can understand uh, the fair contribution of each feature towards the output. So this is another popular technique we have, which explains the importance of features. There are a few more techniques we have, like attention visualization, where it shows you where the attention is given more. So this is specific to a LLM, where you can understand how each word is related to the other words in the given input. Where it has focused more, how each word is related, or any particular input word, how it focuses on other words, right? Where the attention is given more, so that you can visualize it with this technique. And you have laser-wise relevance propagation. This is another technique which is which is used for explaining the prediction. You have Google's what if tool, um, contrastive explanation method, CEM. So these are different techniques we have to explain uh, the prediction. Okay, let me show you. We have something called as where I can show you. I don't really remember now. It's okay. No worries. Let me check that out. So there is uh, one site where you can see. This is not the one. Anyway, let me check it, that. So where you can clearly see how how the prediction is made, how does a model gives an output. Okay, but I missed the link. That's fine. I'll show you if I remember that. So these are some of the techniques we have. So what is the impact of explainability? It mainly helps in user adaptation. So when you can explain your model, when you have the evidence of how does the output is given by a model, right? On what basis the model has given you certain output, right? If you can explain that, you build more confidence. You have more confidence on your model, right? it makes the user to trust your model, right? Rely on your model. So it increases the user adoption. And it is very important for compliances. So let's say if whether your model adheres to the process, adheres to the legal procedures, so regulatory adherence is there or not, so that you can explain, that you can ensure, right, when you have explainability. So this is very much important. It's not just that um, when the uh, when the usage is increasing, right, when it adapts all the industries, it is very important that you should be able to explain the model's prediction, right? It becomes very important. So I can show you one implementation. I'll not take more time. Let me explain this. So I have taken Lime. So if you had to use Lime, you have to install this. I have a simple example here. So let me import all the libraries. I hope you're familiar with Python. I hope everybody knows Python here. So let's import Lime. Here I have imported some of the libraries. So I do a simple classification task here, so for which I have used a logistic regression model, and TF-IDF vectorizer is for preprocessing, and pipeline is to build the model pipeline, and pre-processing modeling, everything can be created. Then line text explainer is something which I'm going to use here to explain the output of the model. Okay, so I have a simple text here, a simple data, where I have a few sentences and their labels here telling which of these emails are spam, okay, and not spam. So here, where 1 is considered to be spam and 0 is not spam. So I'm going to train the model. I have taken a simple logistic regression model, and TF-IDF is for preprocessing. Okay, so let me build the pipeline. And here I'm training the model. I've passed my input and the output. So let me train the model. And once it is trained, I have some text here which has to be checked whether this is spam or not. So I have given the class names as not spam and spam. So I have 1 and 0. Let me use Lime Text Explainer where I have given the class names. So first initialize Lime Text Explainer, and here is to do the prediction. So let's call explainer, and I mean explain instance function where you have to pass your text data. And here this is going to predict the probability. It's to see whether it is spam or not spam. So it gives you the probability for both the classes. And you say how many number of features to be conceded. So you're limiting the number of words here. Only 6 most important words would be taken. And number of samples. So this is what I was telling, like how many modified versions you want. You can, again, these are all adjustable parameters. You can give, any count. So I go with 5,000, which means that there will be 5,000 modified versions of this text. Okay. Now what do? You're going to give a different version. So Lime will create 5,000 different emails, just making slight variation in this text. In one email, it will not have congratulations. In one mail, it will replace or it removes some of the words here, right? It may not have free, it may not have tickets. So it doesn't worry about the grammatical errors and all. It just simply removes some of the words, and it again gives these emails to the model to predict the output. So those emails would be passed to a linear model. So it uses a linear model, which understands how these outputs are given. Okay, so for all 5,000 emails, the modified emails, how the outputs are given, it understands the relationship, it understands how what kind of changes, I'm sorry, it understands what kind of changes causes changes in the output. So which of these words are really important for considering the mail as spam. Okay. So 5,000 emails, the prediction would be done, and the line will tell you which of the words are very important, okay, based on the weights that it has calculated using a linear model. You can see which of the words are very important. So let me show you that. So I have taken the weights and the features. So you get the words and their weights here. So you can see whichever is in dark color, they are all most important words. So it has identified these words are as important words, and you can see the weights, okay, which are in white, they are not important. They have zero importance or zero influence on the prediction. So whichever is in the dark color, these words are very important. And you can see the these colors are based on the weights. Okay, so when you have line, it explains you on what basis it gives you certain output. Okay, it tells you like which of the input word is important for doing the prediction. Okay, this applies same for the tabular data also when you have numerical features. So you could use line, you could use sharp. Here it just identifies the most important features, whereas when you use sharp, it gives you some value for every sharp value for every feature or every word, telling which of those words are considered to be important. Okay, so these are different techniques we have, and this helps you to justify the prediction of a model. So when you can be confident on how you get certain output from a model, it is easy to convince your, it's not about convincing, it is easy to make the client understand, right, how much confident they can be in the model, right? So when you could come up with such evidence or proof, right, then it is easy to make anybody use your model, right? So explainable AI is very important in today's scenario. Without that, let's say you may not, as AI has greater impact on all the industry, it becomes very much important when you are using it for any critical decision making, right? So this is all about explainable AI. If you have any questions, you can ask. Any questions you have?
Hello.
Uh, yes, Asha,
Actually, I missed that portion that is like in line how you are calculating the feature weights.
I'll tell you. So you understood this part, right? How? So let's say when you have a model to predict the output. Let's say your model has given some output. You have this in, let's say, this text where your model has predicted as spam. Okay. So this is the text that I have given, and my model has predicted that this as a spam email, right? Now what Lime does, it just creates a different version of this email where just removing some of the words in some emails, right? Let's say one email free word will be removed, one email click will be removed, one email lottery will be removed, and some words would be replaced. So it creates thousands of emails, okay, of the same text by just doing slight variation in the text. Then it just makes the model to predict the output for this data. Okay, for the emails that it has generated, it will allow the model to predict the output. So let's say if this is predicted as spam, this is predicted as.
Yeah, by doing this, any benefits that we are getting?
Yes, I'll tell you.
Yeah.
So let's say this is predicted as spam, this is predicted as not spam. Okay. Now, what do we understand from here? By just taking one instance, this line helps us to understand for this particular instance how the model has predicted it as spam. It explains on what basis it has given you that output. So what it does, it just modifies each mail, okay, the same mail, it comes with a different version, and this data will be allowed, this data will be given to a linear model, a simple model which just understands which of these features have a great impact on spam. Let's say, for example, here when let's consider this as a not spam. So here, let's say when this lottery word is not there, the model has predicted it as not spam. Okay, but you see in the previous, the original email was congratulations, you won free lottery. So when lottery is there, the model has considered it as spam. When lottery is not there, model has considered it as not spam. Now tell me whether lottery word is important or not. It is important.
Yes.
So your linear model will understand that this word is very important to predict or to assume that it is spam. To tell it is spam or not, this word becomes very important, right? Similarly, with all the input data, it understands which of these words have a greater impact on this prediction. This is analyzed by the linear model which Lime uses. We call this as surrogate model, which is going to just understand what input we have and how the output changes. When I make certain changes in the input, how my output changes. It is analyzed by this linear model. Now this helps to understand which of these words are important. Now how it is going to assign weight. So you know a linear model has coefficients for every features, right? Here our features are words. So we have each word is a feature here. So it gives certain weight based on the change in the output. For this word, there would be some weight assigned. For this word, there would be some weight. For this word, there would be some weight. So this weight helps us to understand which word is more important.
So this weight, what you are telling is like at random, any weights will be assigned or how it will be?
Not random weight.
That
So
we
it
are
fits
assigning
a
the weight
straight
or
line. No. So how a linear model works, it fits a straight line to the given data,
yeah.
right? So when you have a slope, when you have a straight line, there is slope, right? You have
Okay.
weight, and they are called as coefficients,
Yes.
right? Those
Hmm.
coefficients, how they are given, what those coefficients explains, those coefficients tells us what is the rate of change in the output with respect to the change in input, right? So it fits a straight line for the data, okay? But it considers, it understands what is the weight of each feature here, each word here, okay? Based on the output we have, it understands which of these features are important, okay? And these weights are the indicators where it tells you how much influence is there
Yes, yes,
on
I
the
got it. I
output
got it. Thank you. Thank you.
on
I
each
got it.
one.
I understood.
Okay,
Thank you. Thank you.
yeah. Any other questions? So when you use these explainable AI techniques, you can be very sure of your model. Okay, you can justify the predictions. You can increase the user adoption. Okay, so trust is very important factor when you had to use AI models. All right, so that is achieved by these techniques. Any other questions?
Any other questions from the participants? Think no, ma'am. Is it done from your end, ma'am?
Yes, it's done.
I think no more questions, ma'am. Thank you
Okay.
so much, ma'am. That was a very informative session. Thank you so much for being with us. Pleasure having you, ma'am. Thank you.
Thank you so much. Thank you all.
Dear all participants, immediately after the session, we'll be posting the feedback form and as well as the quiz. Please take up the quiz immediately after the session. That will be posted in the WhatsApp group. Thank you all. We'll meet you in the tomorrow session.
Thank you all.
And one more thing to all the participants, as tomorrow is the last day, sessions will be starting from 2 p.m. onwards. So we'll have 3 sessions. So kindly all of you can join by sharp 2 p.m. tomorrow. Anyway, we'll be sending the reminder in the WhatsApp group also. Thank you all.